Lustre is the second distributed file system that we're going to talk about. It's named based on an amalgamation of Linux and Cluster. It is open source. It is currently at version 2 for the stable variants. Has multiple maintaining communities, primarily Intel on the commercial side, and then a number of HPC centers that have gotten together to help maintain Lustre for the community. Implementation is significantly more complicated than NFS. It actually has storage servers and metadata servers, and then similar to NFS, has clients on the compute nodes. Because it has this additional complexity, it also has the opportunity for better fault tolerance, right? So it has parallel compute nodes and or metadata servers. You can decide what degree of fault tolerance you want and add file servers for performance and for redundancy. All this, of course, adds the complexity in the installation and both tuning it, trying to decide for performance reasons, do you need more storage nodes, the object storage servers? Do you need more metadata servers? How do you balance those out for a given number of clients? Has great scalability, near linear, and has been tested regularly at lots of HPC centers to tens of thousands of clients. Again, this depends upon a larger number of clients will require a larger number of metadata servers and storage servers, but that's all still within a single Lustre file system environment, as opposed to building lots of independent NFS servers. That namespace, that hierarchy is not maintained, whereas in Lustre, this is one coherent file system that can handle tens of thousands of clients, and with a nice balance of being able to add more hardware to get the performance that you're looking for. So for that, you get excellent aggregate I/O performance. If you're looking at total bandwidth, in some regards, that just goes up linearly as you add additional hardware. But there's a lot of software to make sure that happens, and reduction in bottlenecks and tuning in Lustre that allows that to happen, so you get sort of this linear aggregate I/O boost as you just continue to add hardware. Really excellent performance for small numbers of large files. Historically, though, and this is different than the NFS, is the small file performance, especially large numbers of small files, has been traditionally very bad. So if you look at the architecture, why would that be? Right, so why would an NFS server do a better job, at least historically, at handling lots of small files as opposed to this robust HPC distributed file system such as Lustre? Well, if you think of that, notice this metadata server. That's not actually storing the data itself, it's storing data about the files, where they're located, maybe potential things about the security and access controls. All right, so when you have lots of small files, there's actually not much data moving, but there are lots of queries to those metadata servers about each and every one of those individual files. So you spend a lot of time dealing with looking up metadata on those particular files remotely versus trying to go ahead and have the metadata itself be coupled to the file. So first you have to go touch the metadata, then you go touch the tiny file, and typically the systems were not balanced for that sort of performance. They were balanced for large files, so you didn't have robust metadata servers, because normally if you have a large file but a small number of them, you're not hitting the metadata server very often. If you're doing lots and lots of small files, you're going to need lots of metadata servers. So a lot of Lustre systems often had to be retuned to handle large amounts of metadata for small files better, similar to small file performance of NFS, which has both the metadata and the file on the same machine.